So yeah, thanks for the opportunity. This is work supported by Chevron, so thanks for the support, and Plant Biosecurity CRC. So this is on the use of drones for detecting buffalo grass in particular. So before this study, there were some satellite and manned aircraft surveys for buffalo grass, but they were up to 25 centimeter resolution. We were challenged with the task, can you detect buffalo grass at the early stages of seedling? And we went and studied at two places, one in Chinchilla in Queensland, where it's pasture, and in Western Australia at Cape Range National Park. Oops. Can you play that video for us? So that's the type of environment at Cape Range National Park. We use a multi-rotor drone with a high-resolution camera about 60 meters above ground to be able to see if we were able to detect buffalo grass. And then we also did it at Chinchilla, and there's really big difference between the environments at Chinchilla and Western Australia. And what you see in that image on your right is that is an image of buffalo grass and other species, green panic, and other species that are really similar to buffalo grass. So in that context, you do need a hyperspectral sensor because you need that level of discrimination between the different species because they're really, really similar. The color picture allows you to see things that perhaps you cannot see visually, those differences. Now, the environment in Western Australia was much more different. So just with a high-resolution camera, we were able to pick up the difference between buffalo grass and other type of vegetation. So here is a high-resolution zoom-in images that we were taking, and this shows the classification algorithms that we use to then map the different vegetation. So what we do is that then we take each of these images and we stitch them together, and then that gives us a really comprehensive map of vegetation and distribution of buffalo grass in that environment. So to give you a sense of a scale, a car, see the point here. A car is really tiny speck in that area. So I guess in conclusion, this helps us to develop a software system that can be used if you have airborne imagery of the landscape and there's buffalo grass in that area. We can apply the algorithms to detect buffalo grass in that context. So it's useful in national parks, in other areas. So if you work in buffalo grass, I'll be interested to talk to you about our experiences and what we learned. So thank you.